Zeal Education Society, redefining excellence.
Hello students, I am Dr. Mahadev Unde, Professor, Zeal College of Engineering and Research, Pune. In this video lecture, we are going to learn the single phase transformer. What is a transformer? Transformer is a static machine which transfers electrical energy from one circuit to another circuit by mutual induction without change of frequency. It works on principle of mutual induction or two mutually placed coils on a common magnetic circuit. The common magnetic circuit is nothing but core of the transformer. So we will draw the diagram, the elementary diagram of the transformer. So this is core of the transformer, and we will show the windings. Say this is IP. This is V1, or we can say I1. This is switch, and when the switch is closed, the current will flow through the winding like this. Now looking from this end, it will become a south pole and this will be a north pole. So obviously it will send the flux in the direction. This is an elementary type transformer. Elementary means very basic. Now pay attention here. The common magnetic, see two coils here, coil 1 say and coil 2 are placed on common magnetic circuit. And we know the mutually induced EMF. When the voltage is applied to the one winding, EMF get induced in the other winding. That is known as statically but mutually induced EMF. Its converse is also true. If we supply on this side, EMF will get induced on this side. Now here, this is the core. The vertical portion of the core is known as limb. LIMB. And the horizontal portion, top and bottom. Horizontal portions, top and bottoms are known as yoke. So the two coils or two windings are wound on the vertical portion, that is the limbs, and they are separately shown here because it is a basic for understanding purpose. It is an elementary type of transformer. The practically somewhat different, we will study it later on. The winding to which supply is fed, this is supply. Obvious? AC supply. The winding to which AC supply is fed or given is known as primary winding, say denoted by P, and the winding to which load is connected is known as secondary winding, S. So this is the basic, very basic. Then see the principle of operation. Now see what happens when a single phase AC supply is fed to the primary winding. The flux will generate in the core. This flux links to the primary winding as well to the secondary winding via core. Then according to Faraday's laws of electromagnetic induction, whenever flux linked with the coil changes, an EMF is always induced in it. As it is an alternating current or alternating flux, the flux is changing. So the EMF induced in the primary winding is known as self-induced EMF, and EMF induced in the secondary winding is known as mutually induced EMF. So EMF get induced in both the coils. Now if the load is connected by putting or by closing the switch, the current will start flowing and energy get delivered to the load. Thus the electrical energy is entirely transferred from one circuit to another circuit by magnetically. There is no here any electrical connections. So the energy transferred from one circuit to another circuit only by the magnetic circuit. So this is the principle of operation of the single phase transformer. Now see the construction. The main parts of the transformers are main parts. First one is core and second one is windings. Now beside these two parts, main parts, there are other parts also, that is the container, then the explosion vent, then the cooling pipes, radiators, conservator and breather, etc. Now let us study the one by one this core. See the material. Core is made up of, it is made up of high silicon content steel. Laminations of thickness 0.35 mm to 0.5 mm are used. Now these laminations are of type, lamination type. Laminations are of I section, L section, E section, U sections. Now these laminations are of SAFE, I SAFE, L SAFE, E SAFE, U SAFE. Okay? Or simply this one. So if you connect here inverted L, it will be a rectangle. So it forms the core. These laminations are insulated from each other by varnish, and the laminations are staggered so that staggering. What is the staggering? Say this is the L section. This is the say first layer. On this side, the first layer will be like this. So on this side it is inverted V, this is inverted L, and this is this L. Okay, the L in the opposite side, or we can consider it like this also. So this is L. Let us put the L on opposite side or inverted L like this. It forms the core. Now the second layer, in second layer, this horizontal portion on the left hand side would be at the top and this portion would be at the bottom. So that is known as staggering. This when you purchase the chappal or a shoes, how they are placed in the box, not one above the other, but they are placed in a opposite direction so as to minimize the size, so as to minimize the air gap. So these laminations are staggered in order to minimize the air gap so as to reduce the reluctance of the path. To reduce reluctance of the path, reluctance of the magnetic circuit, laminations are staggered. So this may be made up of I sections, L sections, or E sections, or U sections. So now this high silicon content material used to reduce the hysteresis losses, and the laminations are used to reduce the eddy current losses. Now consider the windings. These windings are made up of copper material, generally made up of copper material or aluminum material. And they are of two types. One, cylindrical in type, and concentric. And second one is sandwich type. Generally, the cylindrical in type and concentric, this is used for the core type of the transformer. And this is for cell type of the transformer. Now the question is, what is core type? In the core type of the transformer, windings surround the considerable portion of the core. Windings surround the considerable portion of the core, and in cell type, the core surround the considerable portion of the windings. It is the sail of the ground nut. It is just like a sail of the ground nut. The inside part is important, that is winding is important here. So it is a sail, outer covering sail. So first thing is cylindrical in type and concentric, we will see this winding. Now in practical transformer, see this is the elementary type of transformer where we have shown the two windings on separate two lanes. But in actual practice, in spite of saying the primary winding and secondary winding, the terminology used is the high voltage winding and the low voltage winding, HV and LV. So in actual or practical transformer, both LV and HV windings are placed on both the lanes, one above the other. One above the other. Normally the low voltage winding is placed near to core. Means first insulation, then LV winding, then once again insulation, and then the HV winding. I will show the diagram for that. Say this is a core. Now we have to put, say, first thing, this is insulation. Then once again insulation, and this is the winding. This is the cut section, and for simplicity I am showing only one. So this winding is HV winding, and this is LV winding. See, this portion, this and this on both the sides, is insulation. This is insulation used. And this one is high voltage winding. This is low voltage winding. And this one is core. And core is made up of high grade silicon content steel. So here the core, then the insulation generally used is impregnated paper. So in short, paper insulation is used. It is properly impregnated. So on the core, paper insulation, then the LV winding, then once again insulation, and then the HV winding. Now why the LV winding is kept near to the core? Because the insulation required, because LV low voltage, the insulation required will be, thickness of the insulation required will be less. So in order to reduce thickness of the insulation, LV winding is kept near to core. So in this way, both the windings LV and HV are placed one above the other on both the lengths. Okay. So I think there would be no difficulty. And this structure looks like, say, cylinder in cylinder, and that's why the cylindrical in type and concentric. So the name is like this. And another one is the sandwich type winding. Sandwich type of winding is generally used for the cell type of the transformer. I will draw the picture for that one. Now see here, here also this is LV winding, then HV winding, then here HV winding, and here it is LV winding. LV placed near to core, then HV. This is like a pancake. It is in the form of disc. Number of winding discs are connected in series and they are placed one above the other. So here sandwich type winding, and this one is cylindrical. Okay, we have already considered. Now this is used for the cell type of the transformer. It is in the form of disc connected in series, number of discs, and normally it is like a pancakes. It looks like, and the low voltage winding is placed near to yoke. See, on this side also and on this side also, this is yoke. This is also yoke. So it is placed near to yoke and HV winding inside it. Now here it is, for maintenance it is little bit difficult, else it is used everywhere. So in this way we have studied the transformer, elementary type of the transformer. It works on principle of mutual induction. Then the We have seen the principle of operation, then the construction, main parts are core and the windings. We have studied the core is made up of high silicon steel material of the laminations and they are of type I, L, E, etc. Then the various windings, why the materials are used, that is also mentioned. And one more point is, for the transformer, the voltage may be increased or decreased. Here, using transformer, voltage may be increased or decreased with corresponding decrease or increase in current. That means, say, if it is V1 I1 equal to V2 I2, say the rating is 1000 kV. So, and the V1 is say 500 volt, V2 is say 250 volt. So, obviously 500 into 2 equal to 250 into 4. Here the voltage is decreased, less voltage, more current. More voltage, less current. So the using the transformer voltage may be increased or stepped up or stepped down with corresponding decrease or increase in current. And this is required in the power system because in the generator generates voltage at the generating stations, that is normally at 11 kV, 22 kV or 33 kV. However, it is stepped up to 400 kV or 765 kV or 1200 kV in order to transmit large block of power over a long distance across the country. And we will stop here. Thank you.